All right, let's go talk about how to evaluate a function. Note, when you see something written y equals this, right? How do you read that? You say that y equals f of x, or y equals a function of x. So we say y equals f of x. That does not mean f times x. That's what I'm trying to get at. This is function notation. So an example, evaluate the function f of x equals 4x minus 3 at the given x values. What if x equals negative 3? So we want to find f of negative 3. Anywhere you see an x, you're going to plug in negative 3. Looking up here, 4 times x, so 4 times negative 3, minus 3. Negative 12 minus 3 is negative 15. If you're using your calculator, you can store values for x. You turn it on. I'm going to store negative 3 for x, so I say negative 3, store. It's the button right above the on. And I want to store it as x. And I hit enter. Every time I hit the value x, my calculator now thinks that I touched negative 3. So I can type in my function 4x minus 3 and hit enter. And it tells me negative 15. Is that what we got? Okay. So the second one, f of 0. F of 0 is going to be 4 times 0 minus 3. So I should get negative 3. On my calculator, if I say 0 store as x, and now I want to type in 4x minus 3, you know you can hit second enter, and it keeps jumping up, so you don't have to re-enter it again. I get negative 3. Okay, this may seem real silly, doing a linear equation, typing in an x value, but when you have to evaluate like 5x squared minus 7x plus 8, when x is negative 11, do you want to do all that arithmetic in your head? Just type in negative 11 store as x, and then type in the equation, 5x squared, so on. Saves you a lot of time. All right, one more. F of a. What is f of a? You plug in a wherever you see an x in that yellow highlighted function, right? 4 times a minus 3. That's all you can do. I'm going to tell you to go do f of a plus h. F of a plus h is 4 times a plus h minus 3. If you want to distribute the 4, you can. That would be 4a plus 4h minus 3. And you're done. Okay, let's go talk about finding intercepts, finding x-intercepts and y-intercepts. First of all, what is an x-intercept? It's where it crosses the x-axis. So whatever your function looks like, these would be x-intercepts, right? What is a y-intercept? It's where it crosses the y-axis. So on that example, it would be right there. How many y-intercepts can a function have? Be careful. Y-intercept for a function. Just one. Y-intercept is here, right? If it has more than one y-intercept, it wouldn't pass which test? The vertical line test, exactly. So a function can have at most one y-intercept. How many x-intercepts can a function have? As many as it wants. None, one, two, just depends on the function. Okay, to find the y-intercept, right here, what's the x value there? 0. To find the y-intercept, let x equals 0 and solve for y. To find the x-intercept or x-intercepts, let y equals 0 and solve for x. All right. Go do number 1. There are several problems like this in the homework set, by the way. Find the x and y-intercepts. So let's go find the y-intercept first. For the y-intercept, we let x be 0, yes? So y equals 0 squared minus 9. I get y equals negative 9. I need you to give me the coordinate of the point for the y-intercept. It's an ordered pair. 0, negative 9. Perfect. For the x-intercept, I'll let y equal 0. In this equation, where is the y? Y is the same as f of x. So another way to write that would be to say y equals x squared minus 9. You agree? Okay, if I let y equals 0, I get 0 equals x squared minus 9. You can factor the right hand side and set the factors equal to 0. You can add 9 to both sides, which is what I'm going to do, and then take the square root of both sides. So I add 9 to both sides, and I get 9 equals x squared. Then I'm going to take the square root of both sides, and when I do, I have to say plus or minus. So my answer is plus or minus 3 equals x. How many x-intercepts do I get? 2. What are they? They are the coordinates. Negative 3, 0, and positive 3, 0. When I look at the graph of number 1, I can go on my calculator and hit y equals x squared minus 9. Y equals x squared minus 9, and I go graph it. How many y-intercepts do I see? 1. And what's the coordinate? 0, negative 9. How many x-intercepts do I see? 2. And the coordinates are negative 3, 0, and 3, 0. Pretty cool? All right. So I grabbed my graph. Here's one x-intercept. Here's the second one. And the y-intercept is down here. Okay, you go practice on number 2. G of x equals absolute value of x minus 4. A note. Functions can be represented by f of x, g of x, h of x, l of x, p of x. They're usually represented with a lowercase letter. I'm pretty consistent at using f of x, but sometimes you'll see me use g of x. Okay, for number 2, let's go talk about the y-intercept first. For the y-intercept, we let x equals 0, so we have y equals absolute value of 0 minus 4. What's the absolute value of 0? 0. So what is 0 minus 4? Negative 4. So the y-intercept is the point 0, negative 4. For the x-intercept, we're going to let y equal 0. So we have 0 equals absolute value of x minus 4. We need to solve for x. Get the absolute value by itself first, right? So I have 4 equals absolute value of x. Remember how to solve these from last week? You take the absolute value away and you say x equals 4 or x equals negative 4. So again, we have two x-intercepts. They are the point 4, 0 and the point negative 4, 0. If we go graph y equals absolute value of x minus 4 on our calculator, y equals clear. How do you get absolute value to come up? You hit math. You hit math. You arrow to the right under number. And it's number 1, ABS. Hit enter. So I want the absolute value of x. I need to arrow to the right and get out of the absolute value symbols and say minus 4. Yes? Okay, what is the y-intercept? It's down here at 0, negative 4. The x-intercepts are at negative 4, 0 and at 4, 0.